Welcome back, everybody. In this section, we talk about surface waters. How does water on the surface change the landscape of Earth? So what comes to mind when you think of surface water? Well, probably you think about things like lakes and like swamps. And while these are important, they aren't the most important thing when it comes to shaping the Earth's surface. These are more byproducts of another factor. And these are going to be our streams. This is what we're going to focus on for this section. Streams and rivers, more than anything else, shape the way that Earth's surface looks. So what makes something a stream exactly? Well, it's going to be some body of water that moves through a channel, a sort of narrow, defined, clear passageway. You know exactly where the channel is and where it is not. This is our number one factor when it comes to shaping Earth's surface, shaping landscapes, making Earth's surface look the way it does. And it's going to come in three types. We have rivers, creeks, and brooks. Now, here's the way that I like to remember this, right? You're standing at some channel and you want to know if it is a river. Well, you think to yourself, could I pick up a rock and throw it to the other side? And if the answer is no, what you have is a river, going to be our largest type of stream and usually the most important for things like commerce, commercial activity. Now, you imagine you're standing on the side of a stream and you pick up a rock and you can throw it to the other side, but maybe it's too far for you to actually step across. This would make it a creek, going to be another variety of stream, right? So a creek is a variety of stream, a river is one variety of stream, and our last is a brook. So this is going to be small enough that you could step across to the other side and easily throw a rock across it. So we said that streams, are bodies of water that travel through these narrow passageways called channels. Well, what are the different types of stream channels, the different passageways? And we're going to talk about three types: straight, braided, and meandering. So our first type is going to be the straight channel. And keep in mind, you look at this and you say, well, that's not straight. This is relatively straight as far as a river goes. There is no perfectly straight river for reasons that will soon become apparent. These tend to occur in mountainous regions. You have high gradients there, high energy. It is flowing downward at an incredibly fast rate, and as it does, it carves V-shaped valleys and canyons. And because of the high energy associated and the relatively elevated terrain typical of a straight channel, it's going to have more rapids and waterfalls associated with it. So what do we mean, a V-shaped valley? What does this look like? Well, this is going to be a river valley in Yosemite, right? And if you look at the shape made, it's really more like a V than anything else. In fact, we could actually draw on these lines and say that it is about V-shaped. V-shaped compared to what? Well, compared to the more U-shaped valleys. And likewise, if you look at your grandmother's favorite valley, the Grand Canyon, right? We notice a very, very steep V-shape carved out here. So even if you knew nothing about there being the Colorado River at the bottom, if you looked at the shape of the valley, you might be able to deduce that this was carved by a river. Now there's this second type, the braided channels. Braided, it does look kind of similar to braids in somebody's hair. These tend to be a little bit less energy, flatter, lower gradient than the straight types. Usually you have multiple channels here splitting apart and coming back together in a sort of complicated, messy way. You have these little features in between the streams. Now, depending on the size, if it's big, it might be called an island. If it's very small, you just have a pile of alluvium. You could have something called a submerged bar that's somewhere in the middle. Usually, because you have so much sediment here that the river's carrying, these are going to be found close to sediment source areas. So maybe not right on the mountain, but close to it. And these typically have a large but complicated varying load of sediment associated with them. So where did all of this come from? Well, folks went out into the world and they saw river systems that look like this or like this and said, well, there seem to be all these different strands of the river, splits apart and comes back together in some areas, and all of this sediment that's deposited in between them, which is why these are called braided rivers. And based on the amount of sediment that's lying around in these areas, it must be somewhere that's close to a sediment source, like a mountain. So finally, early geologists and researchers went out and they saw these rivers that tend to meander all over the place. It doesn't seem to be going in a particular direction. There's all of these twists and turns. What are these? Well, they notice that these tend to occur in lower gradient areas, flatter areas. Tends to be a single big channel, not like the braided streams. Seems to be characteristic of lowlands far away from the mountains, a lower energy setting. And actually, these must meander and move over time, as evidenced by features that we will look at soon. They tend to form these wide floodplains. In other words, because the area is so flat, whenever it floods a huge area of land. These do flood regularly, again, in part because of how flat the area is, and it seems that many of the longest rivers in the world, places like the Mississippi, tend to be of the meandering type. One of the primary physical pieces of evidence that would have told early researchers that these rivers change frequently over time, the channel moves one way or another, would have been these things called oxbows. And we'll talk in a bit about how these are formed, but know this. If you have a lake right here, well, it seems to be suspiciously close to the same shape as the river. So you might conclude that at one point the river flowed through here and now it does not, it's shifted over. And I've included this to give a visual of what a floodplain looks like. So we have our river, we have relatively high banks, and then we have this huge flat area around it that floods whenever you have a big precipitation event. So if you were an early researcher looking at one of these rivers, you would notice that whenever you zoom out, there's this huge area around the river which tends to be flat and tends to be a little bit different from the stuff that's further out. This is going to be the floodplain. Whenever the river floods, all of this is inundated with water. So we have a flat land adjacent to a stream that experiences occasional flooding. It stretches from the banks of the stream channel, right, the edge of the stream, all the way to the enclosing valley walls. Now, typically the soils in the floodplain are going to be really good for farming. You have this mix of clays, silts, and sands which are deposited during the floods. So if you wanted to talk about a river to somebody else and describe it, what would be the first things you tell somebody about the river? Well, the first thing you would talk about is the gradient. Is it steep or is it more flat? This is going to determine the energy level of the overall river system. Next is discharge. How big of a river is it? Is there a lot of water flowing through it or only a tiny bit? And finally, you would start talking about the sediment load carried by the river. So we know that mountains and all of these different landscapes weather and break down over time, and that rivers erode and carry that sediment elsewhere. But it turns out that the sediment it carries is not all one big mass. In fact, there's going to be a bed load, the bigger pieces, which roll along the bottom. There's a suspended load, the lighter stuff, which isn't quite at the bottom, but isn't really dissolved in the water. It's carried through the middle, kind of like a lazy river. And then you have a dissolved sediment load, which has been chemically integrated into the water. So it's going to be more like putting salt into the water as opposed to dropping sand into it. So I've put this chart here to help tie things together. Now, anytime that you have a high gradient, mountainous, steep area, high energy, you're going to get a relatively straight river channel. The discharge tends to be low because there's just not a huge amount of area where the water will collect in this channel. And we'll talk about drainage basins in a bit, which will make more sense out of this. And finally, the sediment load tends to be a little bit lower, even though it is eroding the area very quickly. We talked about those big V-shaped valleys. The amount of sediment in the channel tends to be relatively low. It's moving so quickly. On the other hand, if you have a flatter area with a ton of water volume, lots of discharge, this is where you're going to get a meandering stream channel, and the sediment load on this tends to be very high. Much of it tends to be suspended within the water, not at the bottom. Finally, if you have an area that's relatively flat, discharge is maybe a little bit less than a meandering stream channel, but it varies. With a high bed load, you're more likely to get this braided stream system. So the bed load is going to be the bigger, denser sediments, more likely to be deposited, dropped off, which would lead to the braided system that we talked about. It's important to note here, a particular stream channel can start off as one type, maybe a straight channel, and then over time evolve into one of the others. That is, streams age. They start out youthful. This is going to be your straighter channel, steep gradient V-shaped valleys, high water velocity. And as it gets older, it tends to turn into your more meandering or braided stream types. So somewhere in the middle, once there's been enough time for it to mature, we have a more moderate gradient. It might carve out a floodplain. And finally, once it gets to be old, the end stage of a river, you think of something like the Mississippi, a huge floodplain, huge volume of water, low gradient, relatively low velocity. Visually, what would this look like? Well, we would start with a useful stream. You would see this steep valleys, relatively narrow river channel, and over time, it's going to erode, might have a bit of a floodplain develop, but still a relatively straight channel, and by the time it reaches old age, it completely meanders. It has these other features. We'll talk about what an oxbow lake is. Now, let's say you looked at it from the side. You could tell this is a more youthful river, a little bit more V-shaped, not a big floodplain. The mature river, you have a relatively broad river channel and then a huge river valley complete with floodplains around it. Now, when I talked about the straight river channels, I said that they typically have a low total volume of water involved. Why is that? Well, first we have to ask the question here, where is all of the stream water coming from in the first place? So what I have here are the different drainage basins. Okay, so here's how to look at this. You imagine that you have rainfall happening right here, and you ask the question, well, eventually once it's been carried down the mountain, through all the rivers, all the way out to flat ground, where does it end up? Well, the purple is Pacific here, so any rain that falls here would eventually wind up in the Pacific Ocean. In other words, if we looked at this whole area in purple, that entire thing is the Pacific Ocean drainage basin. And likewise for all of this area in red, which drains into the Gulf of Mexico, and this huge area which drains into the Atlantic Ocean. And now you might look here, you can see some topography, right? There's this sort of dividing line. All of this flows into the Atlantic, and there's this tiny sliver that flows into the Pacific here. Well, this thing in the middle, as you might imagine, is called a divide, separating the two drainage basins. We could actually take this concept and go one step further with it and talk about individual rivers or channels, right? So here, everything in this green area, you can see it's very big, will eventually, all the water will make its way to the Mississippi River and then drain. Now, likewise, on the opposite side of our Great Divide, Rocky Mountain region, we have the Colorado River, which includes all of Arizona. So everything in this gold-looking region here, all the water that falls there will eventually make its way into the Colorado River. So one more time, just to emphasize, we have all of these different rivers and lakes in Arizona. These all fall within the same drainage basin. In other words, they all fall within this big area which all eventually drains into the Colorado River. So that is it for our section on surface water. In the next section, we'll talk a little bit more about things like oxbow lakes, the different features or landforms that are created by streams.